When you think about it, how do we really learn to do pretty much anything? Riding a bike, mastering a video game, even just figuring out how to get a cookie from the top shelf? We try something, we fail, we try something else, and eventually we get it right. It's all just trial and error. Well, it turns out that this exact same process is how some of the most advanced AIs are learning to master incredibly complex tasks. It's called reinforcement learning, and today we're going to break down exactly how it all works.
So let's stick with that cookie example for a second. Seriously, picture it. There's a cookie jar way up high. How do you get it? There's no instruction manual, right? You might try grabbing a chair. Maybe that's not tall enough. You could try stacking some books. Probably a bad idea. Or maybe you'd even try to lasso it with the belt. Some of these ideas are going to work, and some are going to end in a mess. Exactly. Through all that trying and failing, you eventually figure out what works. And when you do, you get that sweet, sweet reward. The cookie. But more importantly, you learn. You now know a strategy that gets you the cookie. That fundamental process of learning by doing, all in the pursuit of a goal, that is the absolute core idea of reinforcement learning.
Now, we've talked before about other ways AIs learn. You've got supervised learning, where it's like having a teacher who gives you all the correct answers. Then there's unsupervised learning, where the AI is on its own, just looking for hidden patterns in a bunch of data. Reinforcement learning is the wild one. There's no teacher, no answer key. There's just an AI, an environment, and a goal. It has to figure everything else out for itself, guided only by those rewards for a job well done.
Okay, so to really get how an AI learns to, say, walk or drive a car using this method, we kind of have to learn its language. There are a few key terms that turn this simple idea of trial and error into a system that an AI can actually use. First up, we have the agent. This is pretty simple. The agent is just the AI model itself. It's our little learner, our loyal subject, that's out there in the world trying to accomplish the goal we've given it.
And an agent has to actually do stuff, right? Well, any single move it can possibly make, whether that's moving one step forward, turning left, or picking a specific move in a chess game, we call that an action. So, where is the agent performing all these actions? It's always in some kind of situation, a specific context. And we call this its state. Think of it as a snapshot of everything the agent knows at that very moment. Its location, what it can see around it, all of its current data.
And finally, we get to the most important piece of this whole puzzle, the reward. For us, a reward is a cookie. For an AI, it's just a simple, positive signal. It's a little digital pat on the back that says, hey, good job. Whatever you just did, do more of that. This is the ultimate feedback that guides its entire learning process.
Okay, so the agent gets a reward when it finally succeeds. But how does it know what to do along the way? How does it make smart choices that will eventually lead to that reward? This is where two other really crucial ideas come into play: value and policy. This is basically the brains of the operation.
Let's use an analogy. Imagine you walk into a kitchen and you see a closed box, a paper bag, and a plate with one single donut on it. The first thing your brain does is assign a value to each option. It's like a yumminess score. You think, that box could have a whole dozen donuts, so its potential value is high, maybe a 6. The bag might have 2, so its value is a 2, and that plate has one guaranteed donut, so its value is a 1. Now you need a policy. That's your strategy. Your policy could be, always go for the highest potential value, so you open the box. Or your policy could be safer. Take the guaranteed option. The policy is the rule you use to make a decision based on the values.
All right, that was a lot of new words. So let's make this way more concrete. Let's watch our brand new agent, we'll call him John Greenbot, learn to navigate a super simple room. This is going to pull everything we just talked about together.
So here's the setup. John Greenbot is our agent. The room is its environment. The goal is simple: get to the battery. That's it. To do that, it has 4 possible actions: move up, down, left, or right. And its state is just its current location on the grid.
So at the very beginning, our bot has absolutely no idea what to do. It has no map, no instructions. It doesn't know which moves are good or bad because it's never gotten a reward. So what does it do? The only thing it can do, it just wanders around totally at random. It's exploring.
And hey, look at that. After bumbling around for a while, it accidentally stumbles right onto the battery. Success! For reaching the goal, it gets its very first reward, a little digital +1. Awesome!
But here's where the magic really happens. It's not just about getting the reward.
It's about what happens next. The bot now looks back at the long, winding path it took to get here. This is called credit assignment. It starts assigning value to all the squares it stepped on, kind of like leaving breadcrumbs for itself. The squares closer to the reward get a higher value, and the ones farther away get a lower one. It's starting to build its own internal map of which parts of the room are good to be in.
Now that our little bot knows at least one way to get a reward, it faces a really big choice. This is a fundamental dilemma that's at the absolute heart of all reinforcement learning.
And that choice is between exploitation and exploration. Exploitation means just using the path it already knows. It's safe, it's a guaranteed reward, but that first path was really inefficient, right? Exploration, on the other hand, means trying new, random paths. Now, this is risky. It could get lost and get no reward at all, but it could also lead to finding a much, much better shortcut. You know, it's the same choice we make. Do you go to your favorite restaurant that you know is good, exploitation, or do you try that new place down the street that could be amazing, exploration? Let's put some real numbers to this. Let's say that first successful path took 10 moves. If our bot decided to only exploit that knowledge, over the course of, say, 100 total moves, it could complete that path 10 times. That means it would get a grand total of 10 points. Not bad. It's a steady paycheck.
But what if it spent some of its time exploring instead? Yeah, at first, it might wander off and fail a few times, which feels like waste. But what if, during that exploration, it stumbled upon a super efficient shortcut that only takes 4 moves? Well, now, in that same 100-move game, it can zip over to the battery 25 times, scoring 25 points. That initial risk of exploration led to a way, way bigger payoff in the long run.
So this little grid world is awesome for getting the basics down. But you and I know the real world is infinitely more complicated and messy. And this is where reinforcement learning gets really interesting, but also a whole lot harder. Think about it. In the real world, you don't just have positive rewards. You've also got negative ones, obstacles, dangers, black holes an agent has to learn to avoid. You might have multiple kinds of rewards. Some are worth +1, but others are worth +3. And the biggest challenge of all? The environment itself is always changing. For a self-driving car, that means new traffic patterns, different pedestrians, and unexpected construction every single day.
But even with all these challenges, this trial and error approach is leading to some absolutely incredible breakthroughs. We're seeing it in virtual AIs that literally teach themselves how to walk and jump with this uncanny, realistic motion. It's powering real-world robots that are learning how to perform delicate tasks. It's a key part of self-driving car systems. And of course, it's the secret sauce behind AIs that have completely mastered the world's most complex games, discovering winning strategies that no human had ever even thought of.
And that's really the power of this whole idea. By just setting a goal and defining what counts as a reward, we can unleash an AI to figure out how to do things we might not even know how to explain ourselves. But as these systems get more and more powerful, it puts a huge emphasis on us. It means the goals we set and the rewards we design become absolutely critical, which leaves us with a pretty big question. As we build AIs that learn from their own mistakes, how do we make sure they're learning the right lessons?